All right. So, since middle school, when you have been graphing, does anybody know what type of graph you have been graphing on? An XY graph, but does anybody know what it's called? A coordinate graph, we actually call it the Cartesian grid, the Cartesian plane. Have you ever heard of that?
I knew that.
Maybe at one point in your life.
When did we learn that?
Like in 6th grade. It's okay if you don't have that memorized, but yes. And do you agree your coordinate is x comma y? Okay. Today we're going to introduce you to the complex plane. So a complex plane also has a vertical and a horizontal axis. Your horizontal axis is your real number, and your vertical axis is your imaginary number. And do you agree yesterday we learned that a complex number is a plus bi? We talked about that yesterday. So your point would be a comma b. Your real number, comma your imaginary number. Does that make sense? We're going to talk about in a little bit a polar graph. And a polar graph is a little bit different because it has a center, and instead of being based on a horizontal and a vertical axis, everything is determined by your radius and theta, how far it is from the center, and the angle. We're going to start graphing those Friday. But today I want you to focus on the first two. Both of these, do you agree, are rectangular? If I were to outline them, I could make a rectangle. So both of those are rectangular. So it's very easy to convert from one to another. Later we're going to talk about how to convert our complex plane to a polar graph or vice versa. Okay? First thing I need you to know, we're going to focus right now on the complex plane. That's a plus bi. A complex number is a plus bi. We're going to write that like 5 times today. And so today we're going to be talking about something called a modulus. And a modulus is the absolute value of a complex number is the distance from the origin to the point in the complex plane. the modulus, the absolute value of a complex number. It's the distance from the origin to the point in the complex plane. So how do I find the modulus? If I'm in this complex plane right here, how do I find the distance from the origin to AB? I mean, you're not wrong, but give me something else. The distance is not the slope. How would I find the distance from the origin to the point? Distance formula or Pythagorean theorem. So couldn't I, the absolute value of z is the absolute value of a plus bi. That is just a squared plus b squared, square root it. When we dealt with vectors, what did we call this? Magnitude. It's the same thing. These are just same thing, different words. Typically, we do the vectors, complex number, and polar graphs all kind of together in one unit. However, we have winter break in between, so that's why it's kind of broken up. If you talk to somebody who took pre-cal last year, they are probably like, whoa, why are you doing this right now? We flip-flopped complex numbers and vectors. So last year we taught complex numbers before Christmas and vectors after. And this year we switched it. Okay, any questions? So example 1. If I have the number 4 plus 3i, can you graph this? On the complex plane. How would you graph this? You know A and B. What's my A and B? 1, 2, 3, 4. 1, 2, 3. So I know my point is at 4, 3. Y'all agree with that? Cool, we graphed it. Now can we find the modulus? How? Pythagorean theorem. What is 4 squared plus 3 squared? Square root it. 5. And that's it. That's it. That is graphing it. Yeah. That is graphing it. Questions? I want you to try example 2 on your own. Come on, Edwin. What'd y'all get for AB? -2, -1. Do y'all agree with that? And the modulus? Is the square root of 5. Why is it not plus or minus 5? Because it's a distance. Yep. That makes sense? All right. That's a question on your quiz on Friday. One of the questions. Just graph it, find the modulus. Oh, I just... there's 1, 2. $10? Maybe? Maybe 12. Basically, it's one of each part, each example we're doing today, and then one like each section we did yesterday. Yeah. All right. So you can go back and forth between complex number plane and polar graphing. All right. So what I'm going to do right here is I'm going to draw the complex number plane. And if I have a point AB, what do you know about that point AB? It's A plus BI. Do y'all agree? All right. What if I wanted you to convert that to R theta? So instead of AB, what if I wanted this to become R theta? I cannot just make AR and B theta. It does not work like that. How do I find R? What is R? What? And how do you find the radius? Pythagorean theorem. Don't you agree the radius is that right there? So if I'm given AB, how do we find R? It's our modulus. We do Pythagorean theorem. A squared plus B squared, and take the square root of that. How would I find theta? What is theta? An angle from what? Do you agree from the x-axis there? How would I find out what that angle is? No. What'd you say? Not sine. Close. I have A and B. I know what's in blue. What could I use if I know what's in blue? I could use tan. Do you agree this right here is my B value? Do you agree this down here is my A value? And I have the opposite, because I have what's in blue, and I have the adjacent, which is my tangent. So how do I find theta? Inverse tan. Of what?
Inverse tan.
Of what?
B over A.
Of B over A. Why B over A? Because tangent is TOA, opposite over adjacent. So if you are given AB to find R and theta, these are the two formulas you're going to use. Does that make sense? A little bit? What about vice versa? What if I'm given an R theta? move this down, sorry. What if I give you a radius and an angle? Sorry, my circles are not very circular. Or perfect, I guess. What if I give you an r theta? How would you find or convert that to AB? If you know r and you know theta is this right here. Louder? Explain what you mean by that. Give me a different word then. What are we thinking over here? What'd you say? How could I figure out A down here? How could I figure out how long it is? Or B right here? SOHCAHTOA. Why do you keep saying log sines and log cosines? We're not using either one of those. Again. No, I don't think we're using those again. Remember, if I give you r and theta, that's what you know. How do I find A? What's A? Adjacent. And what do I know? R and theta. So if I have adjacent and hypotenuse, I would do the cosine of theta is my adjacent over hypotenuse. But how do I find A? How do I get A by itself? Multiply by R. So A is R cosine of theta. How would I find B? The sine of theta is B over R, or opposite over hypotenuse. So how do I get B by itself? These are the formulas you're going to use to convert that way. What questions do I have so far? All right, I'm going to turn my paper over because I've run out of room. So yesterday we learned or talked about the standard form. So if I say standard complex form, or even if you hear me say rectangular, what I'm asking for is A plus BI. If you hear me talk about standard complex form or standard rectangular form, I'm asking for Z equals A plus BI. But if you hear me asking for standard polar form, I should not have A and B. What should I have? R and theta. So substitute them in. What is Z going to equal? Instead of A, what does A equal? r cosine of theta plus, what is b? R sine theta of I. If you were to leave it like this, that's fine. Do you see how they both have R? I'm not going to leave it like this. I'm going to factor out the R. And I'm going to move the I to the front. If you were to put it at the end, it would not be wrong. This is the formula you're going to see me use. And what I write down to remember it is RCIS. R cosine I sine. If you can remember that, you'll have that one memorized. I'm hoping you already have A plus BI memorized. So the other one is RCIS. Kylie, you with me over there? Okay. So now we're going to do 2 examples converting forward and then 2 examples converting backwards. And we're good. Alright, so let's go from let's convert standard rectangular to polar form. Gerard, are you okay? What do I know? Yeah, you're right. What do I know? A and B. What's A?
1.
What's B? 1. And I actually think on your homework it's going to have you graph it. You can just draw a little small sketch. So how do I convert this to polar form? What do I need for polar form? Radius and theta. How do I find the radius? Pythagorean theorem. Which gives me square root of 2. How do I find theta? Nope. The inverse tan. And what am I inversing for tan? What over what? Ooh, be careful. B over A. In this case, it doesn't really matter, but it will matter eventually. B over A, which is 1. This is where you need to know your unit circle. Somebody's like, what? Let's just think back. Where is tangent 1? What is the inverse tan of 1? Okay. That's the cosine of that, and like you just did 2 things. But, hold on, pause real quick. Something matters here. Because do you agree that there are 2 answers?
Yeah.
So how do we know which one to do? What quadrant is this point in? So that's how you can kind of know, hey, my point's in quadrant 1, my answer should also be in quadrant 1. My angle should be in quadrant 1. Does that make sense? Alright, so just be aware of that. We are in radians. So where is tangent 1? Pi over 4. And if you're like, oop, nope, maybe brain dump that unit circle today when you get home. I have some more blank ones if you want them. Alright, so now we just need to write the equation. And this is where our cis comes in. What's my R? Cosine of pi over 4 plus I sine of pi over 4. And that's your answer. You're not solving it out. You're not doing anything but converting the equation. Leave it like that.
Are we gonna have to solve it later?
No. Because I already know what this is when you solve it. It's that right there. I gave that to you. Yeah. Does that make sense? Do I have any questions? Let's try one on your own. Square root of 3 minus I. Go. Graph it, find your R and theta, and then give me the equation.
I am. You're not.
Just like, oh, this is your A, and B, so it's right here. That's not A, and B, so we just add it on. So here's your A, which is B. No, what number is that? Negative. So just plug it in. Square, like you're guessing. Square root of 3, which is what plus? And so that's how you do it. And you just okay, don't forget your lunch kit. If you are lost or you just want to check, you can look up. Do we all agree that the R is 2?
Yes.
If you put square root of 4, make sure you put 2. Does everybody see how I got the inverse tan of negative square root of 3 over 3? Remember that it's B over A, and then you have to rationalize. Where is tangent negative square root of 3 over 3? Okay, so be careful. What quadrant are we in? The fourth quadrant. Is 4 pi over 3 in the fourth quadrant? It's 11 pi over 6. So the way that I remember this is, do you see how there's 2 3's? What's 3 plus 3? 6. So you know it's going to be over 6, and then figure out what quadrant it's in. So what is my answer? Arcis. 2 cosine of, 11 pi over 6. Don't forget that I. Did you put the I next to the sine? Sine of 11 pi over 6. What questions do I have? Alright, last two examples. Now we are going to go to, I think this is easier.
Again?
Now we got to go the other way. We're going to convert standard polar to rectangular form. Now we're converting standard polar to rectangular form. Again, I personally think this is easier. Alright, what do I know? My radius is 3. Theta is pi over 6. So if I wanted to graph this one, and I don't think we're going to ask you to do that, but it would be somewhere like right here at 3 pi over 6. But again, I don't think we're going to ask you to graph this. So how can I do this one? Just solve it out. What's the cosine of pi over 6? Oh, we didn't forget everything. Plus I. What's the sine of pi over 6? And then distribute. So this is going to be 3 square roots of 3 over 2 plus 1/2 I. And that's it. Nope, not 1/2, 3/2. Sorry. Distribute that 3 to both of them. My bad. Questions? You're just solving out. So do you now know what A is?
Yes.
Do you now know what B is? Yeah. All right, last one. Sorry, let me fix that. There you go. Z equals 5 cosine 135 degrees plus I sine of 135. Get me an answer, please. What's the cosine of 135?
Negative square root of 2 over 2.
Plus I. What's the sign of 135?
Positive.
So therefore, z equals negative 5 root 2 over 2. Ooh. Plus 5 root 2 over 2i. Okay? Alright. Hold on real quick. We are done. A couple things I want to tell you. Number 1, again, your homework is due tomorrow. Y'all have about 12 minutes left. I'm going to put it on the board. You can probably start this. You can do it on graph paper or notebook paper. Somebody asked me, can I do the evens on that same notebook paper? Yeah, you don't have to turn in the legal sheet, but you can turn it in. You can staple them together tomorrow. So the legal sheet, I got to get you. The legal sheet is what we did yesterday. It's all the evens. And then bookwork is the other one. So get started on those. I'm going to put up the page problems right here for you.